Hello YouTube, welcome to my shop. So before I get started in this particular video, I am going to be working with 240 volt AC open connectors on the bench where everything is going to be open. I don't recommend it. If you don't know what you're doing, don't try to replicate what I'm doing in this video. I've spent a lot of time working with open power. I'm used to actually doing it. I know when not to touch things and when to and that kind of stuff. So I do have some experience with that. I've done quite a bit of work on radios and whatnot when I was in the military, and we had high voltage equipment that we had to work on with power on. So like I said, I mean, this is high voltage stuff and it will kill you. On that note, I'm building a rotary phase converter, a bit larger than I actually originally wanted. I was looking for around 15 horsepower, something big enough to start the closing. At some point I'll probably remove the variable frequency drive and off of everything and just run this off a three-phase normally. But until then I wanted to have a rotary phase converter mainly to power the bandsaw. So when I started looking at putting a variable frequency drive on the bandsaw, it had a few hiccups on it. So for one, it's got a welder, blade welder, and a grinder also on it that are running off of three-phase power. For me to actually power that, I would have to put two VFDs on it and probably run a regular 220 line. So that was starting to get to be a little bit more than I really wanted to tackle with that. So I started shopping around for a rotary phase converter. One popped up on Craigslist, 30 horsepower. Quite a bit more than I really wanted. But on Craigslist, he didn't put the horsepower, so I pinged him out. I was like, hey, what's the horsepower on that? And he said 30. I'm like, oh, sorry, that's a bit more than I really want. And he actually replied saying, well, you always want to go bigger because, trying to sell it a little bit. And I kind of blew it off for a little bit, and I was looking around. There was another one that came up. It was a little bit more than I wanted to spend. It was like $800 or something. And I ended up replying to the guy. I was like, hey, if you can let it go, what was it now? $600. I'll take it. And he's like, sure. $600, you come get it. Hooked up the trailer, I got it, brought it home, started looking, reviewing different schematics, reviewing different videos online, going through a lot of information, just trying to get a full grasp on it. Plus just going over what was in there, what existed, how it was wired, and all of that. So I kind of got it figured out, and then I started putting things together. Went through, figured out how to do the contactors, getting everything so it would start and stop, adding a little bit of safety to it so that if you lose power, it doesn't come back on afterwards. It's a relatively simple switch, but it's not intuitive if you're not used to working with switches. First thing you got to do is just get the idle motor spinning. So I was able to do that using some start capacitors. Eventually I got it running really well, started balancing it out with the run capacitors. Got the balance really good, plugged the bandsaw into it, everything powers up beautifully, runs nice. In this video, I'm going to kind of go over this. I've actually already done it all, but I've pulled everything apart. So this is going to be the final time before I actually assemble it in its final configuration. I'm going to go through and kind of act through the discovery and learning and how the contactors work, and going over the full install that I went through to make this thing work. So let's head over to the bench and see what we've got. Okay, so this is the board that I'll be doing the work on. I've got a little bit of chicken scratch on here. Some of it meant something when I wrote it. Most of it I'm not using that to actually wire much of anything. I do have the 240 single phase coming in here. 243 phase will be coming out of this side here. Start capacitors will be controlled through this contactor, and the main power will be controlled through this contactor. My main 220 comes in here, And this is the pigtail that I have that will be wired up for the power that comes into it. The motor is down there on the floor. That thing's a beast. Perspective wise, you can't really tell, but it's a couple of feet off that direction and down on the floor, so it's big, trust me. So the first thing that I want to do, just for safety's sake, is test out my incoming power. And just putting my electrodes in here, I should get 240. So 239.8, that's good. Now I want to double check my ground. So going from any leg to ground, I should have 120 volts. So going this way, 118.7, and going this way, 121.0. So my lines coming into the house here aren't perfectly balanced, but now I know that my ground is good, and I know I've got good power coming in. As it is right now, if I plug that in, these would be live wires that are out in the open. So I want to get past that first. So let me go ahead and plug these guys in. And then this is my ground bar here. It's got one wire that comes and grounds to this metal plate here. This contactor doesn't really have a grounding point, so don't have anything running to it. Alright, so if I plug that in right now, these two guys here would be live. These two would not be live. It's basically an open circuit. It's not going to do anything. So what we have to do is to activate this contactor. So inside of here there's a big electromagnet, and there's 3 switches, because it's technically 4 3-phase, even though this phase had burnt out in the old one. I don't know what it used to go to, but it's got some pretty nasty damage to it. So down under here, these guys are what activate the contactor. And looking at the data plate, it needs 240 volts, and it will activate the electromagnet that's in there and pull the switch down. That's something you got to check depending on the contactor. Some of them are 120, some of them are 240, so always double check on what your contactor needs. For wiring this up, we now need to add a switch. So I've got a little toggle switch here. This is the small switch that we can run smaller wires to that'll activate the big switch that runs the bigger wires. Basically that's really all this is for. Otherwise you would just run, a regular switch, but you don't really want, giant switches with springs and chunk and everything happening. This makes it a little easier just to turn on and off. Alright, so we're going to come off of here and go into our switch. Like that. And then we're going to come out of our switch and go into one side of our power. And then the other side of our power we're just going to run straight down to the other side of our switch. So now we have power coming into the switch. We have a path going from that power to the contactor's activator relay wired into a little toggle switch here. I'm going to go ahead and walk around over here so I'm not reaching over top of anything and plug it in. Okay, so now we've got live connections here, so hands off. This little connector will now, when I throw this switch, you'll hear the ka-chunk. And that's activating it. These 2 leads here are now hot. If I release it, activate. Release, activate. Okay. Now one problem that this has, this is activated right now. If we lose power, it shuts off. Makes sense, that's good, right? It shuts off. But if power comes back, it turns back on. Now if this is connected to the motor and nobody's around to see that and come in and flip the switch, we lose power. Then when power comes back, the motor's going to start spinning. It's not going to be able to spin up. It's going to be drawing a bunch of extra amps, and something's going to burn out. So this type of switch isn't really what we need for this. Let's go ahead and pull this apart. And here I have a momentary switch. When you press this down, it'll establish a connection. When you release it, that connection will go away. So first, let's wire this up exactly as it was before, but with this particular connection, so you can see how that works. All right, and then this guy. All right, back around here, plugging this in. Everything's live, have to be careful with it again. So what this gets us now, press the button, activates it, release the button, it deactivates. So that's a little bit safer, but not as useful. If I want to run a piece of equipment, I'd have to sit here and hold this down, run the equipment. When I was done, release it. So while if we lose power, I'm not going to sit here and hold the button down when power comes back on. It's not going to be a problem. But as it is, this isn't going to function the way we need it to, because it shuts off. So what we need, I'm going to go ahead and unplug it. So what I'm going to do is I'm going to trick this circuit. When I hit this button, it's engaging the contactor. When I release it, the contactor is not getting power anymore, so it releases as well. So what I'm going to do, I'm going to replace this wire here with this wire, which it was sort of sitting here. It actually comes from the other side. So the idea will be, I turn on the switch, it'll activate it. When I release the button, the contactor will stay activated because now it's going off of the other side and it'll stay running. Okay, for a quick demonstration, I'm going to go ahead and plug this back in. Now we've got a little bit of a problem in that if I turn it on, it's engaged. If I release the button, now it stays on. So it doesn't disengage. So we're getting closer, at least now if I pull the power. I don't know if you heard that, it disengaged. Power comes back, it does not re-engage until the button's pressed. Now it's staying on, remove power, and it goes away. So to fix that, that's what the off switch here is. So it actually works as a disconnect. The on switch is open when it's up, and it closes the circuit when you press it. So that's what turns it on. The off switch is the opposite. So it is closed when it's up, and you open it by pressing down on it. So what we're going to do, so we're going to wire the stop side in and replace this wire with the stop side of the switch. So now what this should do, when I hit this button, it engages the contactor, which connects power from here to this side, which then keeps the contactor engaged when I release it. Then when I hit this side, it should disconnect the other side of the switch, cutting power and releasing the contactor. And when I release that, it shouldn't come back on. Let's make sure that that works. Nothing came on. Now over here, hit the contactor. Contactor came on. Release. On. Off. All right, that works. Unplugged. Now with this setup, we have power coming in. We can hook up the motor to this side. All right, so now the idler motor is actually wired in. If I try to start the motor now, it's not going to start. I'll give you a quick demo. What happens, the motor just kind of chugs a little bit and doesn't spin all the way up. Leaving it like that for any length of time will burn it up, so this will just be a really fast demo. All right, so I'm going to plug it in. Everything's live. So if I try to start it now, it just kind of hums like that. So what we need is a start capacitor to get this actually running. That's what this other contactor is for. Remove power. So in order to get a three-phase motor to run off of single phase, we have to actually trick it into having that additional phase and getting power to it. And the way we do that is with start capacitors. So I've already measured these out. I don't remember the exact formula, but to get a 30 horsepower motor, I needed, it was like 900 microfarads, so it ended up being 4 of these capacitors. This gets connected, starts the motor, and then gets disconnected. So they will hold a charge. There is this high ohm resistor that I put on here that makes sure that they discharge afterwards. Otherwise they can shock you. So you want to be very careful with that. So the actual use for the start resistors is going to be coming into this additional contactor. And that will be plugged in with these guys here. And then that connection will come over to one of the 220 legs. So that'll be coming off of this guy here, going into the contactor. When this contactor engages, it will engage the start capacitors, get them charged, and that will dump extra power into this third leg. Alright, so now those capacitors are wired into here. If I turn this on right now, they're not going to do any good because this contactor won't engage. We need to wire another switch into the system to engage the start capacitors. Just so happen to have a momentary switch right here. Alright, so I got coming off of our power lead here, going into this momentary switch, coming out into the contactor, and then back out to the other power lead. These guys here are actually to run the light. I can go ahead and plug that in really quick. Alright, so the little yellow light here will come on whenever power is applied. It's not very bright, so I don't know if it's going to show up on the camera. So at this point I have the start capacitor wired into the third leg. This will actually start and run the motor. You can hear the new contactor. And the motor's up and running. We are actually generating three-phase power. That's sort of our goal of what we're trying to accomplish here. When that motor starts spinning, because it's an inductor, it starts to generate power that comes back in on all three legs. So if I start this guy up again, with my multimeter, and I check my power here. I have 236 volts, so it dropped a little bit because there's a load on it. I check this side, I should have the same thing, because that's just a direct connection. But now if I go over to my third phase, I'm getting 200 volts there. If I check across this link, I'm getting 207 volts there. So that's showing me that I am generating three-phase power, but the voltage isn't consistent. Really, I should have higher voltage going to the ghost leg than I do going across the powered legs. So what I want to do is add capacitors to bring that voltage up, which will help with the starting power. Alright, to speed this up a little bit, I've actually already measured out all of the capacitors and kind of bundled them together for this particular layout. And then finally, part of the circuit, you actually run a capacitor across your two powered legs in order to bring the running amp of the motor down a little bit. And it doesn't take a lot, so I just have one capacitor that runs on there. And that is, you just clamp an amp meter on one of these lines, add a capacitor, see what it does, juggle it up and down, try to get that amperage to come down just a little bit. So now this becomes basically the full phase converter. I don't have actual power hooked up to it without hooking these guys up. So let's go ahead and do that now. And then this is just another pigtail that goes to a three-phase connection that I have over by the bandsaw. So what we're going to do with this is we're just going to wire it directly into here, exactly how the motor is. Alright, so as this is set up here, it's a functioning phase converter, and I could actually run the bandsaw off of it. If we want to see how it actually works, we plug in. Now it's up and running. If we follow the pigtail, it comes down across the floor and is plugged in here, which in turn powers the bandsaw. It is a little noisy, and I'm going to bust it open and I'm going to find out most of the noise is coming from the variable speed drive. So I have to find out why that vibrates so much, but that'll be a different project. For now, now that I've gotten everything functional on the bench, I'm actually able to power the bandsaw or cut some steel. The next task will be to actually move it all off of the bench, get it into a little bit safer space inside this box here. I also have a few amp meters and voltage meters that I'm going to tie into it as a permanent setup. And then I've got a couple of plugs. I'm actually going to just mount these plugs directly into this box here This will be my three-phase box, my three-phase out. The single phase will go in here. All of the equipment will go down there. Three-phase will have two outlets on here, plus at some point there'll be an outlet coming out here going to wherever might need it. This has been a pretty long build, and it's been a little bit touch and go at a few places. Still a little bit worried right now. Sometimes it has a hard time starting, so I can try to engage it, and it looks like the motor starts to spin the wrong way, and then it kind of just vibrates back and forth. If I shut it off fast enough and try again, it'll usually start right up. Otherwise it blows the circuit to the shop and I lose all power. Did get these little volt and amp meters hooked up, and they're actually running off of the three-phase lines. After getting that set up, I did kind of realize I probably should do one more, put over here, and have it on the incoming power. Because normally if I'm not running any equipment, these all just register zero, so I don't actually know how much idler motor is pulling in amps, you know, while it's just sitting idle. So having one more of these little meters, they're pretty cheap. I think they were $13 each or something. I'll order one more of those and mount it over here. I did add these two plugs. One is a L1520 and the other is an L1420, which I'm not sure what happened, and I think most everything, like what I can buy at Home Depot and whatnot, is the L1420. I was looking on Amazon and I saw this L1520 really cheap, and I just kind of misread the label and just ordered them. And so I ended up with one plug set that's this L1520 that I threw on the bandsaw. And it can plug in to this guy here. This works out pretty well. I have basically two outlets on here, and the future option will be to mount a bracket onto here that can actually run power through the whole shop. So that's still open and not set up currently. Do a quick scan through the wiring. It's a little bit of a rat's nest. I'm not real excited with how pretty it came out, but it is functional, so I'm not going to worry too much about it. A little bit of a spaghetti mess in here, but it works and everything's hooked up. These are the amp selectors here, the three actual main phases. I don't really like this because there's no protection in between them. I might have to come up with something for that. Input comes in here, output goes out to the motor this way or up into this box through these guys, and then it brings these two plugs online. These are the volt and amp meters. I got the switch that controls the starter capacitors, and then the on switch, and of course the off switch or kill switch. I'm going to go ahead and put the panel back on and fire it up. So the first time it didn't seem like it wanted to engage, so I cut it off quick enough. I let that sit for even more than about 2 seconds, and it'll kill power to the shop. Not sure if I need bigger startup capacitors or what, or smaller, who knows. I don't think smaller was able to start the motor though. But here you can watch the different phases. Black phase is actually the one that comes across. That's the input phase. And then the other two are the ones that come off the input phase through the ghost leg. So that's why these two are higher than the middle one. They kind of balance out as load comes in and out. I'll turn on the bandsaw. So there you can see it with the bandsaw actually running. I can bring up the grinder. I haven't actually done that. I haven't run them both. See what it looks like. So there was a slight jump when the grinder started up. The grinder was really quiet. You won't hear it over top of the bandsaw. I'm going to go ahead and shut off the bandsaw. So there it is with only the grinder running, which looks like it may actually just be running off of single phase. That's somewhat interesting. Alright, here I'm going to go ahead and start the bandsaw in high and crank up the speed. There's something with the variable speed that it just seems a little noisier than it should be. So here we go.